Escalona, and it's about scalable big data testing. It's from the medical domain, it's metadata solutions, but I guess you will
Sure.
have a few words on it.
Absolutely.
Okay.
Thank you, Rudolph. First things first, we'd like to thank the ICST committee for being selected and for us to present our paper. This was a collaborative effort between the authors, Nam Lee, myself, Yoon Gao, and Jeff Offit. This was an exercise where industry and academia practices truly intersected, so it's pretty cool to see that. Metadata Solutions is one of the leading providers of cloud-based technologies. Our platform enables life science companies, academic organizations, and biopharmacies to conduct better, faster, safer clinical trials. We use a lot of AWS technology to deploy a good chunk of our code. Examples of AWS technologies we use are EC2 for cloud compute, S3 for cloud storage, RDS for relational database like MySQL or SQL, and EMAR for Hadoop processing. Hadoop is an open source software framework used for storing and processing big data on large clusters of EC2 compute nodes. At Metadata, we compute, store, analyze terabytes of clinical trial data through an ETL process using Hadoop EMR. One advantage of AWS is the capacity to store data. We generate a lot of trial data, and now we can take that data to mine it, analyze it, and use Hadoop so that we can understand trends and be a lot more experimental of our data. These technologies allow us to push the edge of innovation and leadership to come up with forward-thinking solutions for our customers. Next, this slide shows a typical approach for big data testing. At a high level, we are dealing with huge data and executing them across compute nodes. Executing them across compute nodes increases the chances of bad data at each stage of the process. Generally, there are 4 validation points to data functional testing. First one is the pre-Hadoop validation. Data from source or sources are extracted and loaded into HDFS before additional processing. Typical scenarios are validate data requirements, ensure correct data is extracted, also validate files are loaded into HDFS correctly. Next is the MapReduce validation. Hadoop jobs, typically written in Hive or Pig, are executed once the data is loaded onto HDFS. And typical scenarios there are validate data processing is complete and output files generated, validate aggregation and consolidation of data after MapReduce process. Next one is the ETL validation. Once MapReduce is completed and data output files are generated, the process data is moved into an enterprise data warehouse like Redshift. Finally, report validation. Analytics reports are generated using reporting tools such as Business Objects by SAP or SAP, and Tahoe or Spotfire by grabbing data from Redshift. Typically, we validate views or displayed as per business requirements. I'm going to play this quick video here. Just imagine this guy is a typical big data engineer, and he's seeing that his ETL job is taking 2 weeks to process. I think the video is not working. Must be a bug in the system. But this guy gets pretty pissed off, so he ends up.
What happens is basically he freezes.
It's supposed to be really funny, and you guys are supposed to laugh. He ends up throwing his keyboard, laptop, everything out the door because he's frustrated. I think I'm gonna have to continue. It's okay. We can just continue. So problems. Our paper addresses 3 problems. Testing a large data set is very expensive, especially for our clinical trial data, we deal with terabytes of data. It's expensive and takes a really long time to process, especially in an agile SDLC life cycle. We want to have provide immediate feedback to our customers, or product owners or developers. And the second and third point is where and how to validate data transferred and transform data. Next, Nan's going to talk about the test framework. So I'm going to hand this off over to him.
Thank you, Anthony. So in this paper, we have identified 3 general problems. We have high volumes of test data, and we have many transition points, and we don't know where we need to do validation. And third, we have to validate the data, and we are already identifying 2 kinds of transitions. One is data transfer and one data transformation. At data transfer point, the data are not changed. But at data transformation point, data are transformed and changed. So on the left side of this figure, this shows we have data coming from different projects. And those data are stored at different locations. Anthony has shown some Amazon-based locations such as Redshift, S3, or other Amazon-based relational databases or NoSQL databases. We also have used the regular relational databases and NoSQL databases, such as MySQL or MongoDB, for instance. Since one of the problems is that we have a very large data set we have to process during the ETL scenarios, so we want to generate a very small data set for development, so they can get a quick feedback during agile software development cycles. And then we also want to use this test framework to provide us as much as automation it can have. We want to use the test automation to provide a test generation and to automate the test validation. So at the transition points for data transfer and transformation, we need to use test framework to do the validation. The one difference from the validation of data transformation from validation of data transfer is that we need requirements because we need to verify whether transform are correct based on the requirements. Next, we are going to see how we can use this test framework in the software development cycles. We view a normal development cycle to have 3 phases: pre-commit, commit, and post-commit. During the pre-commit cycles, we collect the requirements and do some analysis and design software. And after we're done with the design and we need to implement our software and develop our unit tests. After we complete the implementation and during the post-commit phase, we need to develop integration tests and end-to-end tests. Because we know if we fix a bug at a later stage, for instance, the software has been released, we're going to pay a higher cost. So we want to provide the quality as early as possible. So we want to provide a good test set at the pre-commit stage that can be used by developers to develop the software. And once the developer is done with the implementation and we want to validate the data transfer and transformation by creating tests. So next, I'm going to talk about the solutions for 3 general problems. But for this presentation, I'm going to focus more on test data generation, because currently this is our top priority, and this is the foundation of our solution to the big problems. We identified 3 major challenges. So first one is we have different kinds of data in different kinds of structures. For instance, data may come from databases, and data may come also from JSON file, in a different structural format or XML. Currently, in industry, more people prefer JSON to XML because using JSON has less overhead. And second challenge is that how can we generate a representative data set? How to define the representativeness? We'll not just create a small reflection from the original data source based on statistical distribution. We also want this small data set satisfying different constraints, such as referential relationships, some special values with small special ranges, some business constraints. For instance, because we're doing the clinical trial software, and for instance, we conduct the pharmaceutical companies using our software to conduct different studies. For example, we may have a constraint saying we want studies that are coming from 40 different countries. And we may also have density constraints when we're using referential relationships. This constraint specifying how many referred objects have to be included in referring object. For instance, a study may have one participant or have 100 or 30,000 participants. This is a different kind of constraint. Sometimes machine learning techniques is required to use to generate some representative data values. Another challenge is that given the fact that we have terabytes, even petabytes of data, how can we generate a test value quickly? And last but not least, we have historical data, but also we're having live data every day, every hour, every minute. And also, because we're developing software in agile cycles, requirements are changing continuously. How can we generate data that reflects the latest changes of constraints and the data? Those are our summaries about challenges. Remember, keep in mind, our goal is to generate a small data set. And also we have structural data. So if we consider attribute from structural data as a test input, or if we consider a column from database table as an input, so we have different inputs. And we want to reduce the domain for test inputs. So one basic testing technique that we want to use and adapt is called input-space partition testing. This is also called combinatorial interaction testing, or CIT. I think many of you have known this technique. I will just go over these techniques very briefly for people who are not familiar with technique. So first we collect all related test inputs, and we define the domains for every test input. And we use a characteristic to divide the domain into different blocks. Those blocks have to satisfy two properties. First, the blocks do not have overlaps. Second, all the blocks have to cover the whole domain. This process is called creating input domain models. For example, if I have an integer string and the characteristic is to find edge values and some important values, and then we just find the main value at maximum value and 0. And the whole domain will be divided into 5 blocks. And then we select test values from these 5 blocks. So instead of testing to power of 32 integer numbers, we just can simply test 5 numbers. Then we use combinatorial coverage criteria, such as each choice or pairwise coverage criteria to generate tests. Next, we're going to see how we use test framework in the big data context to use this input space partition testing. So in the middle, in this box, this is a test data generator, which is part of the whole test framework. This is working at the surveys and listening the requests from internal customers and external customers. On the right-hand side, it's the same as the part shown in the previous slides. We have data coming in from different projects, and those data are stored at different data sources. And at the metadata, we have different groups working using different programming languages for different projects. So but different projects still share the same data. So we already identifying two kinds of data. So first one is called is coming from the original data source called the historical data, usually in terabytes or petabytes. And we also have the coming daily incrementals. External users enter live data continuously from laptops, smartphones, tablets, or any other embedded devices. And when they enter those incrementals, we put those streaming data in an Amazon-based web service called Kinesis. In Kinesis, we can collect and analyze the live stream data in real time. And usually after 24 hours, those data will be pushed to another data source, and on the next day, we're getting new data. If data are in a different data structure, for instance, other than databases, usually we use parser to pass those, for instance, if the data are in JSON structure, we need to analyze those structures and find out all the attributes and identify the test inputs from the JSON structure. And also here I want to mention, currently software currently is designed for internal customers, but potentially we want to release as a product for our company for external customers. So they can send requests to our services, and then we will respond with a URL that they can use this URL to access our data. I want to highlight this title because this is cutting edge stuff. This is new. We just came up with the idea on our way to GRAS. So this is not on the paper yet. From the process I described, and we generalized this concept, self-adaptive input domain models, we call CDMs. What we're doing here is actually we getting historical data, we're getting incrementals every day, and basically we're creating IDMs and update IDMs. So basically this is input domain model has to be adaptive to the big data context. So at the very beginning stage, we collect the constraints and original data, and we process the original large chunk of original data using EMR Hadoop to get the information, and we use those information to use some statistical analysis and data mining to get the analytics results. And based on those results, we create an initial input domain model, and based on the input domain model, we generate tests using combinatorial test coverage. So this is the first cycle. After the first cycle, we show this test to product managers who are the stakeholders, because we want to satisfy our customers, and also show this to architects, managers, engineers, and we get feedback. And there's the feedback for the next cycle, and if we have feedback, this will be used to, when we use the data mining techniques to analyze those feedbacks and to improve our input domain models. On the following cycles, we don't need to database from one of our clients. And this client has about 3 gigabytes, about 10 million rows, and we selected about 24 objects from the databases, something around 7 million rows, and we were able to shrink the large set to about 200 rows. And also we used the basic constraints such as referential relationships, some spatial values, and also some sort of like less density constraints. And it only took 6 minutes. And this could potentially, our ETL validation cycle could be reduced from 2 weeks to minutes. And also it is easy to use the tool. The users only need to provide connections to the data sources and also provide the configuration files that constrain, that specify different kinds of constraints. Okay, I'm done for the test generation. So next I'm going to talk about the solutions about the other 2 problems. This is the same picture you saw previously. Here I just want to identify the different transition points. So from source to the HDFS, basically this is data transfer point, and from the data warehouse to resources also another transfer points. But we from the Hadoop to data warehouse is data transformation. Based on our experience, we think we just need to verify the source and target. We don't need to verify the middle points. We only need to verify middle points when we need to diagnose bugs. And so when we validate the data transfer, because the data before the transfer and after transfer are the same, so we know expected values. So this can be fully automated. For data transformation, we specify 2 data plans at different levels. At the coarse grain level, we can extract the data types and data ranges from the requirements, and then we automate the validation. But we want to do is to validate the detailed transformation rules against the requirements. We want to convert requirements into some specification language, and our test framework can read the language and automatically convert to tests. But this is ongoing research. This is not done yet. In another way, we can also use a small data set to verify data transformation. In conclusion, in this paper, we identify 3 general problems when testing big data applications and propose general solutions. For data generation, we propose an idea CDMs, and we need to create and maintain the CDMs during for the big data context. In the future, we want to use machine learning techniques into our web services and also process data for different clients, such as Johnson & Johnson. We have a terabyte data from Johnson & Johnson. So that's a practical challenge. Thank you for listening.
Thank you very much. Questions? Yep.
So you mentioned that you use data mining statistics to get the attributes for the inputs for the domain model. Can you estimate how much manual intervention you still need when specifying the first version of the model, and how much manual intervention you need after you get the feedback from the stakeholders?
So as I mentioned, like when you use a tool, you need to provide some inputs, such as attention to the sources, and especially you need to provide the constraints. What kind of constraints you want to, like the final data sets can satisfy. So that's the manual work.
Just the constraint, not the inputs themselves?
Inputs. So for databases, basically you just need to provide the connection. But for JSON structures, basically we need to write a grammar. For instance, we use the JSON to store data. It's not like comprehensive like the normal ones like every company is using. We have this semantic meanings in our JSON structure, so we have to write a grammar to understand how many test inputs are included, what properties embed that the JSON data, and then we can continue then do the analysis after that.
Thank you.
Further questions?
Yeah, I have a question. You mentioned that the stakeholders of the brain. Can you hear me? I don't like microphones. Reminds me of Carol. You mentioned the stakeholders are architects and developers and testers. When in the development process, in which stages is this framework used? I'm thinking of load testing. I'm not familiar with testing big data, but I think at a certain point during your development life cycle, it makes sense to test on the real big data set.
Yeah.
When would you usually use the smaller representative data sets?
Yeah, so I want to I'm not sure I hear you correctly. You said stakeholders are architects.
So you mentioned the stakeholders of the tool.
And so people will review our tests include stakeholders, architects. So they're not saying. Okay, so I just want to make sure that's correct.
Okay.
Yeah. So like the product managers, they're like stakeholders, they representative of our customers. And also we have architects, managers, developer, engineer, test engineers, so like different kind of people. And also you said like when we need to process our data sets, right? So currently, we have to, when we do end-to-end, when we do unit testing or integration testing, we basically manually create the data sets. So that's what we do currently. And for end-to-end testing, we have to process original data source, like terabytes data. So that's why I showed that 2 weeks. So that's just too much. And if we use this our test framework, I'm thinking for the unit testing and integration testing, they can use our automatically generated data sets. And for end-to-end, at some point, still need to process the whole large data sets to make sure it's correct.
And when is this typically done? When are the tests starting on the production data set, on the big data set?
I think it should, after integration testing, right? We want to do end-to-end testing at some point. So initially we have to process the small data sets, but at some point, currently, this is absolutely new. It's still under development. This has not been released to production. We still doing experiments, try to improve our this tool and techniques. So I may not get the exact date or time for your question. Yeah.
No, it's, my question is answered. Thanks.
Okay. So thank you very much.